The distinction for the longest recorded motocross jump goes to an Australian called Robbie Madison. In 2007, he achieved the longest successful bike jump in the world. The planning it took was nothing short of amazing. His specially tuned Honda CR500 stunt bike would have to leave the ramp at exactly 94 miles per hour to avoid overshooting or undershooting the pre-approved landing spot. With thousands of spectators cheering, Madison took a few speed runs back and forth across the ramp, visualizing the perfect launch trajectory in his head before committing to the ramp at full throttle. Emerging triumphant on the other side, Madison's jump of 322 feet cemented him as the best stunt bike jumper the world has ever seen. The flight of the bike during the jump is parabolic and is considered to be a projectile motion because it's only affected by gravity and air resistance while in movement. If the height of the bike is a function of time, we could work out for how long it's above a certain height, giving us a range of times. Let's explore quadratic inequalities and try to understand this. So hold on tight. This is Think 4. Sometimes the question will just be given to us as a straightforward quadratic inequality like this one. Here, we're asked to solve 6 minus x squared is greater than 0. Quadratic inequalities can be solved using something called a table of signs, but most of us solve them by sketching the parabola and looking for the regions above or below the x-axis. So the starting point to solve this is to sketch the curve. To do that, we need to find the roots by making the quadratic equal to 0. Then we factorize and solve it. The roots are at x equals -3 and x equals 2. This is a quadratic with a negative coefficient of x squared, so the shape is parabolic with a maximum turning point as shown. The original quadratic inequality asked us to solve where it is greater than 0, so we look for the region above the x-axis and don't include the roots. In this case, the region is described by all x values where x is between -3 and 2. We write this as -3 is less than x, which is less than 2. Be clear where your answer is, as it's likely you will have roots labelled with x equals on the page too. I like to be clear that I was finding the roots for the sketch, and then I double underline my inequality as shown. Sometimes you will form a quadratic inequality while solving a question. For example, here you're asked to determine the range of values for which the curve is strictly increasing. From your knowledge of the differentiation topic, you should know that a curve is increasing when f-x is greater than 0. The derivative is 3x squared plus 6x minus 24, and so we now have the inequality we need to solve. The sketch will help us find the range of values. We factorize and solve to find roots at -4 and 2. The shape is parabolic curve with a minimum turning point. We're looking for the region where the quadratic is greater than 0, so this is above the x-axis. There are two regions we need to describe, the region where x is less than -4 and the region where x is greater than 2. Quadratics describe the paths of many objects in flight. Let's look at this motocross stunt again. I expect Robbie Madison was pretty sure he'd put the down ramp in the right place before he took off. And if there'd been objects to jump, he'd have wanted to be sure he was going to clear them before he started. The practical applications of quadratic equations and inequalities are many, but they also appear often in this course. So whether you're a stunt rider or just want to pass higher maths, it's really worth knowing this stuff well. This was Think 4. Thanks for watching.